Okay, the countdown is here. 5, 4, 3, 2, 1. Yes, I'm so happy I can be here. I've been locked for 2 years in a cage, and I was sitting there coding something, and I couldn't go to any conferences at all. So I'm happy that I can finally be at my favorite conference here. So thank you for stopping by. I'd like to introduce you to the work that I was working on in the cave. And that relates to heap dumps. So during those 2 years and even few months before that, I actually learned a lot about heap dumps, and I'm willing to share the knowledge right now. Just one thing changed. A month ago, I left Oracle Labs, and now I'm working for Enzo, developing first world visual and textual programming language. So I'm not going to be looking only at the past, but I will have few reflections of the future as well. My name is Jaroslav Tulach, and at the end of last century, I founded and also architected NetBeans. And based on all the design experiences, I wrote practical API design book summarizing all the mistakes we did. And based on that book, I actually got invitation to join Oracle Labs and work on GraalVM, which is what I was doing last 7 years. And yeah, I will talk mostly about GraalVM, mostly about the work I've been doing for last 2-3 years. But now, based on actually, guys from Enzo are building a language on top of GraalVM. And they were looking for someone who has some experience with GraalVM. And they actually could not find anyone better than me. So they convinced me to join. So now I'm an Enzo. OK. So first of all, I talk in general, what is a heap dump? How can we get it? But then the more interesting stuff should appear, because I will talk about how to actually analyze heap dumps programmatically, not only just by using some tools and looking at the heap dumps. And then even more programming stuff will come, and I'd like to look at how we could actually generate heap dumps. Not only analyze them, but also create ones. And at the end, I will talk about replaying such generated heap dumps. OK, let's start with a demo. Let's switch to JVisualVM. So my favorite way of monitoring what is happening with all the Java virtual machines that I have is to use VisualVM. VisualVM allows me to easily select from one of the local processes, open them, and I get some overview of what the process is, what it does, how it was started. And I can even monitor it to find out how much memory it is using, when GC is happening, and so on. But for purposes of this talk, let's focus on heap dumping. So let's click heap dump. And now we should get a heap dump overview. So heap dump is basically a snapshot of the memory at a certain point of time of your Java application. So the summary basically says how many classes, instances, class loaders, and other things are in the heap dump. We can also see here in the VisualVM UI what are the most frequent number of instances and number of allocated bytes, and so on. So then we can switch to some deeper view and we can analyze objects. I guess you know this, but just to make sure that we are on the same page, I am repeating this. So you can find your class, you can visit instances, and in the instances you can find all the references and all the fields that such instance has. So this is a regular stuff that probably everyone is using from time to time. Something that I discovered after a few years of using Visual VM is that a part of the heap dump is also a stack trace. Well, it's not that surprising because if you have a stack trace, if you make a snapshot of your running Java application, then the important thing to understand what is kept in the memory are so-called GC roots. And GC roots are static fields, some references from native code, but especially references from local variables. So for that, it's basically natural that, or necessary, that a thread dump needs to be part of a heap dump. So here we can see all the threads and also all the local variables that are there and that refer to some objects in the heap. Okay, so enough of clicking. The thing, because we are programmers, is we want to write code. And Visual VM actually offers you so-called OQL console, Object Query Language Console, where you can write your queries in JavaScript or enhanced form of JavaScript, which is called OQL and looks like a mixture of JavaScript and SQL. But okay, I will focus mostly on, no, I cannot make it bigger. Never mind, I'll show this sample many times. So next time the letters, the font will be bigger. Okay, so what we have here is basically small JavaScript program which works with an object called heap. And there are many operations on the heap objects. Let me show you some of them. So if I just execute the script heap, we should see what methods are available on that object. And there are things like give me a list of classes, for each, iterate through all each objects, give me list of finalizers, and so on. Okay, but the sample script that I prepared is actually going to ask for iterating all objects of type integer array, and then we will try to find those that are larger than 255 elements and put them into an array. And at the end, we return the array. So let me run the query. And there are some there. Actually, that is too much. So let's make it slightly smaller. So, okay. Fine. So there is eight arrays that are larger than 65K of elements. So this is quite a nice way how to analyze heap dumps, because rather than repeatedly clicking through the heap dump and trying to find out whether certain class is there, you can actually write these scripts. And there are some prepared scripts by Visual VM. So samples include things like list of all Java IO file instances. And here you can see the syntax, which is a mixture of SQL and then sometimes a JavaScript. This SQL-like syntax actually gets converted into JavaScript and is then executed as JavaScript. Okay, so that's Visual VM. And let's return back to slides. So I cannot say, I cannot price Visual VM more. And that's also a time for question. Is there some someone who used Visual VM? Some people? Okay, good, yeah. In the latest poll that I've seen, there was an answer that 40% of Java developers think that Visual VM is one of the, or use Visual VM regularly. So that basically reflects the number of hands in the audience. Actually, Visual VM can either be obtained standalone. So if you visit the website, Visual VM GitHub.io, you can download it standalone, or you can download it together with GraalVM. And that's also the reason why I'm talking about it, because Visual VM is being developed by my colleagues, my former colleagues in Oracle Labs. And another reason for mentioning Visual VM is that the Visual VM application is built on top of NetBeans platform. And that has an interesting consequence. Because NetBeans used to be an IDE. It is still an IDE, but I would not expect many people to use it. But it also used to be a modular application framework. But what it is still, and NetBeans is still being developed and still produces all its components, all its modules as libraries. And the module for doing the OQL, for executing the query, and the module for representing the heap dumps are available on Maven Central. So we actually, as Java developers, can take the power of Visual VM and put it into our applications. And that's what I'm going to try right now. Okay, let's switch to some IDE. And I have a code snippet prepared here, and you can see the imports. So the most important one, or the most important library, is this profiler heap library. And that allows us to actually load any heap dump into memory and start analyzing it. So let's try that. So, heap dump, get Java class by name, and let's look for the integer array. And in the integer array, we want to get all instances. And iterate through them. And let's print them out. OK, let's run it. And there are a lot of them, but we at least see the type. So because we are looking for primitive arrays, the type is primitive array instance. So let's cast it. And now we can call some methods on that array. So found array of length. OK, let's run it. Oh, and I forgot to filter out only the large arrays. So let's do that right now. OK, and now we should get few of them, OK, and their sizes. So if you are a Java developer and working, for example, in quality department and receiving a lot of heap dumps, like the guys working in quality department of NetBeans used to, then you want to analyze them somehow, and preferably not manually. If you want, and here is a way how to do it. If you want to write Java code, you can do it exactly like this. However, we were talking about OQL. So let's also try to use OQL. So engine, new OQL engine, heap dump. And engine has a method execute query. So we execute some code, and here we want to do some, get some callback. It's okay. So the code should be the same as we have in Visual VM. That was not this one. That was the long int array. So I'll just copy it all and insert it into the string here. And then let's basically take this instance of check and put it into this callback as well. I can delete this. Oops. I can delete this command. And that might work. Found in OQL. So we can understand that the messages are coming from a different source. OK, so first of all, we are running the Java query, and now we are running the OQL query. So if you actually want to create an application that would allow someone else, some users, not you as Java developers, but some scripters, to analyze heap dump in JavaScript, you can easily do that as well. All that is needed is to add a dependency, and the dependency is actually this one. So the whole project is a Maven project, and the module in NetBeans is called profiler OQL. And if you add that dependency, you can basically, in your own applications, use the same capabilities as I have just demonstrated. Slides. Yeah, and by the way, there is a project that does exactly that. So if you want to just git clone and not start writing that from scratch, you can visit this project and start from there. OK, so the summary of the demo. All you need to do is to add a single dependency. You can write either in Java, or you can execute object query language. And when you execute the object query language, you actually need some JavaScript engine. Old versions of JDKs were coming up with the Nashorn, but which is no longer part of the JDK, but still can be downloaded as a Maven dependency. Or you can use GraalJS. And I have personally seen significant speedups when using GraalJS over Nashorn. So I would recommend to try GraalJS. OK. But not only to try GraalJS, what I would like to explore now is to actually try to do the same thing to actually analyze a heap dump from a command line, or from a Python or JavaScript using GraalVM. So again, let's switch back to the IDE, and let's take a look at this JavaScript file. So again, there is the common script that I'm using through as a main theme of this presentation. So looking through the heap object for each object that is int array and trying to find out the large one. But the important line, or the new line, is here on the line 2. So what I'm doing is I am using polyglot, which is a capability of GraalVM. So in GraalVM, you can actually mix languages. You can call into Python from JavaScript, or vice versa, into Ruby, into R language, into any language that is written on top of GraalVM. And when I say any language, I mean really any language, not only programming language, but even a language called hprof. So, oops, yeah, okay. So hprof is a language that actually takes a heap dump, loads it into memory, and represents the heap dump as an object. And the object has methods like for each and so on, so on. So then you can basically, from any language, use those methods to analyze the heap. Okay, let's go into the shell. And let's try it. So I need GraalVM. I need JavaScript. And the script here is called query heap.js. Okay, so now I'm going to run it, so it fails. It fails because what I'm doing is I'm invoking a JavaScript interpreter. And by default, this JavaScript interpreter only interprets JavaScript. But because we are in GraalVM, we can actually specify that we want polyglot support. And in such case, we should get access to all other languages in the GraalVM, including the hprof language. So here is it. And basically, the result is the same as expected. So we analyzed the heap dump and got the right result. Of course, we can do something like that also in Python. Python is modern these days. Many people think that Python has a brighter future than JavaScript, and I certainly hope so. But GraalVM supports both. So for GraalVM, there is a little difference. Again, we are using the polyglot capabilities of GraalVM, and here we are evaluating this file, and we want to parse it as by the language hprof. We get an object back, and then we just use the for each method on that object to find out the large array, return them back into array, the usual stuff, let's say. So again, bin, GraalVM EE, Graal Python is the interpreter. I need to enable the polyglot mode. And now, run qh.py. So Python startup is slightly longer, but then we basically get the same result. Okay, so this is basically what you can get from GraalVM Enterprise Edition 21.3. And the numbering basically means that that's the long-term support release that has been released last year. So basically the most recent long-term support release. So if you want to analyze heap dumps with, from a command line like this, then GraalVM Enterprise Edition is for you. However, I mentioned that GraalVM is extensible, and that you can extend it with your own languages. And this is basically the part of the talk when I'm going to talk about my future, because this is the Enzo language. As I mentioned, it's a textual language as well as visual one. So this is the textual representation, and it basically looks like some functional language. And well, actually, this is a demo that I hacked. So use the polyglot capabilities of GraalVM to actually load the hprof file on a given path with the hprof language and return the object. And as soon as I get the object by calling this sample heap method, I can start to work on that object and start to invoke operations. So here I'm, for example, searching for a list of all names, class names in that file, and printing that. Or I can ask for some specific class and then analyze a super constructor and so on, so on. And I should be able to run it. So Enso, run, and this one is called, main Enso. The startup is not great. We still have to work on that. But basically what we are seeing here is I'm printing only the class names. So the class name of javalang integer is javalang integer, and the superclass name is javalang number. So yeah, but I hacked this together only yesterday. So this is basically the textual representation of Enzo. But the thing why people believe Enzo is interesting is actually its visual representation. So I can basically take the same program and open it up in Enzo IDE that will represent it as a set of nodes and set of edges describing the data flow. And what I can do is I can click somewhere here and actually check the real value. So not only this is a like static programming language, but the whole system is constantly running. It is alive, and you can see the values. So now here we basically see, okay, so here we see that superclass name of integer is javalang number, and here we see the list of classes or class names in the heap dump. But what I can do is I can basically drag and drop and select, oops, that's not visible, so let's do it once again. Sorry. Okay, I can drag and drop and then select an operation. So if I want to know how many classes are actually in the heap dump, I can directly invoke a length. So the proposal here is that for power users that handle Excel quite well, you can actually achieve or construct your data pipeline easily just by drag and drop. And we hope we will be successful together with the GraalVM polyglot capabilities. Okay. So this is an intermezzo summary. So heap language is part of GraalVM 21.3. So if you want to use it, just download GraalVM, and you have to download Enterprise Edition. So I probably made a mistake, because 2 or 3, maybe 4 years ago, we were actually asked to find a value differentiator for Enterprise Edition over Community Edition. If you may not know, Community Edition is completely open source and free. Enterprise Edition needs a license. You can evaluate it for free, but then if you use it in production, you would need a license. So we were asked to find a differentiator, and I said, wow, analyzing heap dumps, that is going to be a differentiator. We have to put it into Enterprise Edition. Yeah, I guess I made a mistake, because right now I don't have access to the source code. But yeah, hopefully, yeah, I will continue trying to convince the guys that stayed in Oracle Labs to move it to open source. But meanwhile, you can at least evaluate it in Enterprise Edition. If you try to use that, you will be able to analyze the heap dump in any language. And now it's time to ask for questions. So if you have questions related to this part, let's ask now. And where is the slide? Oh, yeah, preview stop. Yeah. So I guess I answered this question with my demo, where, yeah, if you are a Java developer and you are comfortable writing Java code, you can actually use the profiler library and just work with the heap object directly. You don't need to use the OQL at all. But yeah, sometimes for prototypes, for modifying the query, JavaScript or some other language may be more comfortable, more easy to use. And the other reason for using these scripting languages is you can actually run these scripts in a sandbox. So you can create a website that allows your users to put there a heap dump and put there a script. And you can run it for them on your server. And it can be completely secure, because these scripting languages in GraalVM can really run in a trusted sandbox. So in such case, using these dynamic languages might make more sense, even for Java programmer. OK, no more questions. So that's good. Well, here is it. How to deal with big heap dumps, for example, 30 gigabytes. Well, yeah. I don't know what is the limit. Can we create such a huge file on a disk? Well, probably, right? Otherwise, we would not get that heap dump. So then the library in NetBeans and Visual VM is actually using mmap files. And for smaller files that can fit into, I think, 2 gigabytes, it will just create one mmap segment. For larger files, it will actually move the segment, create multiple segments to cover the whole file. So, and then based on these mmap data, the library is going to create some index in memory. So you don't have to load this huge heap dump into memory. It will stay on a disk, just being mmap into virtual space. And the only thing that is in memory is the index. So hopefully, even such a huge heap dump should be processable. Where exactly the GraalVM EE is needed? GraalVM EE provides the hprof language. So all the examples that I showed that were using something like eval hprof language with this path, that require GraalVM EE. Otherwise, yeah, you can run with just the library and GraalJS. That is going to work as well, but not for Python. If you, for example, want to write scripts in Python to access the heap object, again, you would need the GraalVM EE. OK, thanks a lot. Let's return back and let's cover another topic that was puzzling me during last 2 years. So when you look at the heap dump, it actually feels like a graph database. There are objects, and they have references. And there is also a way how to get back references to some object. That can be traversed. And in addition to that, there are classes. So each object belongs to some class. Moreover, we know that there is a thread, a list of all threads with local variables. So it looks like a general purpose format. And when I started to investigate that more deeply, I even realized that it is a streaming format. The former definition of the hprof format is that it is composed from segments that can go one after another. So a hprof file does not need to contain just a single snapshot of your application. It can have many snapshots next to each other. And I just said, OK, that's great. We could actually use it to record what the application does and then replay it later. And because I was also interested in dynamic languages, I didn't want the Java heap, but I wanted to generate the heap myself. So I wrote a small library that allows us to generate the hprof file. And here is an example how you would do it. So basically, this library is, again, available on Maven Central. It is fully open sourced. It comes from GraalVM. So it is in namespace or GraalVM tools inside. And then it's called the heap dump. And it contains this class. And what you do is you start a builder. And inside of the builder, you can decide to dump heap. And this basically means let's dump one segment. And inside of the segment, we want to define a new class, create an instance of this class, another instance of that class, define another class. And when you define a class, you need to specify what fields it has. And then you just dump it. And at the end, yeah, there can be also like cyclic references, which is basically demonstrated here. And at the end, you can also define a few threads with their stack traces and define what variables are visible in each of the stack frame. OK, so this way, you cannot generate the full hprof format, but for many purposes, it's a good enough format, and it is fully compatible with the specification. So if you execute this program, you can actually generate a hprof file and then open it in Visual VM or in Math Analyzer, in any format, in any tool that understands heap dumps. OK, so this is a usual summary that I give, but we are not finished yet. But we all know that GraalVM can give you high performance, that even languages like JavaScript and Python can run quite fast. It is well known that when you jump from one GraalVM language to another, you can do that at zero cost. It really works quite well, jumping between languages. And the interop is quite smooth as well. For example, you can access an object created representing a heap dump and all the nifty objects and the graph database behind that. So all of that is possible. But the important thing, the third important thing that GraalVM gives you is tooling. There is a lot of fantastic tools, and they all work across all the languages. So I'm just going to talk about GraalVM Insight, which is the pet project that I was working in the cave. And yeah, so first of all, a quiz. Who knows what is aspect-oriented programming? Few. Who is using Spring? Well, that's almost the same group. Aha, that explains something. Yeah. So aspect-oriented, so when I demonstrated GraalVM Insight to my management, one of them basically said, wow, that's like aspect-oriented programming. But that's so 90s. It's so last century. Nobody talks about aspect-oriented programming anymore. Nobody does, but still people use Spring. And behind that, there is this aspect-oriented programming. So GraalVM Insight is basically aspect-oriented programming for dynamic languages. And it can be used as, for example, programmable debugger. And it has a great integration with the heap language. And now I'm trying to try to demonstrate that. We need an IDE, and we need a script. So this is my JavaScript version, well, JavaScript function that can compute factorial of 6. I can run it. So bin GraalVM JS, and it is called factorial JS. And oops. Yeah, actually, I need to go to a different directory. OK, so I can run it, and I can basically get the result, of course. I don't know what to say about it. Anyway, the important thing that I want to talk about is the Insight script. An Insight script can be script written in any GraalVM language. I'm usually using JavaScript, but I could even use Java if I wanted. And what it does is it offers some global object called Insight. And with that object, you can specify or spread your code around your code base without modifying it. So what this onEnter method does, it actually says, whenever you enter a method is called root. So root true means enter a method or a function. And the function is named ACC, which, if you remember the previous source file, is somewhere here. Then, please print out this message and include in there the value of n from the parameter that is coming from the local variable of that function. So the function has parameter n and v, because it accumulates the multiplied numbers and then returns them back. So print out n and v for every time the code comes into this function. So I can use it with inside parameter. Inside, and I need to specify the script, which is surprisingly also called inside.js. And if I run it, we see basically that those two programs get merged together. So without modifying this factorial JS program, you could apply the advices in AOP terms, insights in GraalVM terms, and apply them, and you basically spread these statements, which I have here, to every place where the insight is applicable. Okay, so this is simple stuff that was working in 2 or 3 years ago, maybe even before COVID. But then I realized that actually if I dump this information in some more structured format, I would be actually then able to replay them, because this looks just like a log file. You log something, but then when you have a log file, you need to somehow process it and understand the messages. And it would be better to just replay it. So that's what I tried with these 8 lines hidden here. So instead of printing, of just printing the values, I am recording the current location and recording the local variables into a set of events, and we should get 6 of these events. And at the end of the execution, I am going to use another global object called heap to dump these data into an hprof file, which brings us together to the previous topic of this presentation. So what I'm going to do is to use the same insight, but I need to specify where I want to heap dump this file. So heap dump factorial hprof. So I run it, and in this directory I should get the factorial hprof file. Just created. And I can open it as a regular heap dump. So I can open it in this IDE. And what is actually important is the set of threads. And we should have actually six threads. And each of them is representing one event that we wanted to dump. And whenever we look at the event, we can actually see the local variables. So here we see that variable n is 6, v is 1. And if I move down through the execution, we can see how the values here on the right side are changing. And that basically allows us to trace the execution. So heap dumps are great, not only for recording state of your memory, but also for seeing what is, or recording state of execution. But of course, well, this is not the nicest way to actually look at the recorded data. It's a heap dump, but what we would like to see more is a debugger-like experience. And the good news is that with the GraalVM Enterprise, you can do that. GraalVM Enterprise actually contains an integration of this hprof language with Chrome Tools debugger, or maybe even other debuggers. I could do that in VS Code and in NetBeans as well, but let's do Chrome. So I need to invoke a command which is called polyglot. And I want to process file that I've just created. So that's the hprof file. And now I want I want to enable debugging in chromdev, which is called inspect. And I want to instruct the hprof language to replay it. So replay. So that means it not only so basically the hprof language is capable to load the hprof file in memory and return you the handle so you can analyze it. But in this case, we don't want to just return the handle. We want to replay every step that we recorded. So for that is this option replay. And hprof replay. Aha, okay. So one of the previous questions on Slido was, why do we need the Enterprise Edition exactly for? Well, for this option. So I need to switch to Enterprise Edition because the hprof language, all the commands, the command on the command line interface that use the hprof are only available in the Enterprise Edition because I made a mistake. Yeah. Never mind. So here is the URL which we are supposed to open in Chrome DevTools. So let's place it here. And we can actually see the original source code that we had. We can see the values and we can step through these recorded events just like using we would do while debugging, while using this debugger in a natural mode. But right now, there is no code running. So basically, all the so this can be quite useful if you, for example, are running some scripts in a not in a cloud, somewhere remotely, and they start to fail. Then you can enable this recording capability of GraalVM Insight and record the execution. And you can even record like as many events as you want. You can put there so-called watch points, so basically places where you want to watch something, and generate the hprof file. And once you have the hprof file, you can download it to your local computer and replay it, just like I'm replaying it here. So hopefully this feature is going to be useful. OK. I have 3 minutes, so that's probably time for questions. Or I could demonstrate that this works with Enzo. But yeah, let's probably do questions. That will be, if there are some. There is none. So in such case, let's demonstrate Enzo. So not only I managed to get the previous demo with Enzo IDE working, but I also can record the execution in Enzo language. Because of the promise of GraalVM, because GraalVM promises that once you write a language or once you write a tool, the languages and the tools will be able to work together. So I have a factorial written in Enzo language. Again, there is a factorial function and then inner function with accumulator that accumulates the data. And then I had some bootstrapping problems. I needed to, OK, I removed the previous heap dump, so we know that we are recording something. The bootstrap is currently complicated. I needed to write a Python script that then calls into the Enzo language, but I can start it like this. And basically, it is supposed to work somehow. So the hprof file has been generated, and I can again open that in Chrome DevTools. So I open new tab. And now, instead of seeing the recorded execution with JavaScript, we are seeing the recorded execution with completely different language that the Chrome DevTools don't understand, and neither does GraalVM integration, original one, until it was extended with this language. OK. Back to slides. So I think it's time to summarize what I wanted to talk about. And yeah, it's tough, I guess. because I was talking about so many things. After 2 years being locked somewhere, I just had so many things to talk about that it's hard to pick up one thing. And they say that a presentation should have one thing that everyone shall remember. So what it is? That GraalVM provides great tools? Well, yeah, it does. That there are great libraries that you could actually download from Maven and use them in your own applications? Well, yeah, GraalVM does that. Be it, for example, the library for generating hprof files, or be it a GraalJS scripting engine. NetBeans does that with the profiler heap library. So yeah, feel free to do so. There are, of course, GraalVM provides a lot of ideas, but probably most important one is that GraalVM is a great place to hang around. So I'm going to continue to do so, and I encourage you to try to explore that place as well. Thank you very much for your attention.